So today we're going to talk about factoring special products. In order to factor using special products, you're going to need to remember that there are two types of special products. One is perfect squares, the other one is difference of squares. So you can always factor like normal, but factoring using that special product pattern will actually cut things down considerably for you. But in order to use a special product pattern, you have to identify if something is a special product. So going back, the perfect square pattern is going to always result in a trinomial. So anytime you see a trinomial that has a first term that's a perfect square and a last term that's a perfect square, I'd check to see if it's a perfect square pattern first. So here is a perfect square pattern, perhaps. Here's a trinomial. So let's look. If I find the square root of x squared, is that possible? Yeah, it's x. Is it possible to find the square root of 9? Yeah, that's 3. And now to identify if this is a special product, specifically if it's a perfect square, I need to make sure that this linear term is the correct linear term. In order to do that, if you remember, that linear term should be 2 times the first times the second. So I'm going to check. 2 times the first times the second would be 6x. So yes, this is going to be a perfect square. Now I have everything I need to know. I'm just going to plug them into parentheses. So x and 3, and we know that's going to be squared because it's a perfect square. With the sign, you pull the sign off of the linear term. So the linear term has a sign of minus. So in your binomial, that sign is going to be a minus as well. Let's skip down and look at C here. So C is a trinomial, so it could potentially be a perfect square. So can I take the square root of x squared? Sure can. It's x. Can I take the square root of 16? Sure can. It's 4. So now we need to check to see if 2 times the first times the second is our linear term. So 2 times the first, x, times the second, 4, is 8x. So is this a perfect square? Not a perfect square, because 8x and 4x are not the same. Okay, so let's go back up to B. So B is a binomial. Anytime you see a binomial that's two perfect squares separated by a minus, it could potentially be a DOS. So to figure this out, we're going to have to take the square root of the first term, 25g to the 4th. So the square root of 25 we know is 5. The square root of g to the 4th. So any power that is even we can take a square root of. And it's just the number divided by 2. So the exponent divided by 2 is 2. So the square root of 25g to the 4th is 5g squared. Then we take the square root of 16g squared. So the square root of 16 is 4. The square root of g squared is g. So now that I can do that, I can fill in my two binomials. Remember, for difference of squares, one is a plus and one is a minus. So 5g squared plus 4g, 5g squared minus 4g. And there you go. You factored using special products.